You will find on the other side of the notes, you still, well, kind of shifting a little bit from the unit circle. Okay, we're shifting a little bit from the unit circle. Now, what I have here on the left, y'all already know, or you should know, right? Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, tangent is the opposite over the adjacent. You may not know this part, that tangent is equal to sine over cosine. Okay, tangent is equal to sine over cosine. So I think the way that I understand the standards, they mostly focus on sine and cosine in Math 3. But if they were to ask you a question about tangent, we don't have tangent on the unit circle. We have values for sine and cosine on the unit circle. So if they were to ask you what's the tangent of pi over 6, you would take the value for sine and you put it over the value for cosine. You put the y coordinate over the x coordinate to find the tangent. Now, there are fractions. So fraction divided by fraction, how do we handle that?
Reciprocal and then
multiply by the reciprocal, right? We take the bottom one, we flip it over, and we multiply, okay? So that's where the tangent comes from. Also, I don't know that they'll necessarily ask you anything about the reciprocal functions, but here they are. Can't hurt for me to tell you about it. The reciprocal of sine is cosecant. Okay, CSC is the cosecant. The reciprocal of sine is the cosecant. So that's the hypotenuse over the opposite. Reciprocals flip things over. So cosecant, so reciprocal of sine, so it's the hypotenuse over the opposite. Secant is the reciprocal of cosine. So the reciprocal of cosine would be the hypotenuse over the adjacent. Cotangent is the reciprocal of tangent. So cotangent would be the adjacent over the opposite, or cosine over sine. Now, when you're trying to keep these straight in your head, notice none of the cos go together. We've got sine and cosecant, cosine and secant. You don't have cosine and cosecant. Those don't go together. You don't have two cos together. Sine and cosecant, cosine and secant, tangent and cotangent. All right? So don't pair any of them together. Each one has a C. There are no two C's. All right? All right. So let's say there's a problem that asks you. Let's see here. I've got all these instructions here, but let's look at what the actual. Okay. So say the question is find the ratio given by the ray. Okay, find the ratio given by the ray. So here's what you need to do. You want to draw a ray that starts at the origin and ends, here's the example, at -5, +12. So we are in what quadrant? -5, +12 is in the second quadrant. Okay, -x, +y, second quadrant. So I've got the second quadrant there. I've got just the second quadrant there on your paper. So put that on there, okay? We want to draw a vertical line that goes from the terminal point directly to the x-axis. Okay, so let's draw what we've got here. We've got -5 right here, +12 here. We're ending up right out there, so we draw a line. There's the ray. We want to draw a vertical line from that point down to the x-axis. Well, guess what that forms? A right angle. So what we have is we have a right triangle. Let's look at next. Label the sides of the triangle with their lengths. So this side down here, now measurements are never negative, but we need to include the negative in there. Okay, we need to include the negative in there. So that's -5. The horizontal side, or not horizontal, vertical side over here is 12, because that's the y coordinate, so that side has a length of 12. We need to label theta. That's the angle formed by the ray and the x-axis. Theta is down here. Okay, theta is down here. So what we're going to be doing is we are going to identify all 6 of the ratios. Well, in order to identify all 6 of our ratios, we need all 3 of our side lengths. So if our legs are 5 and 12, what's the hypotenuse? 13. Y'all remembered. 5, 12, 13. Special right triangle. 5, 12, 13. If you didn't remember, Pythagorean theorem. Okay, Pythagorean theorem. So let's label our sides with opposite, adjacent, and hypotenuse. Okay, obviously we should be good with the hypotenuse is the 13. If theta is down there in the right corner, then 5, the negative 5, is the adjacent, and the 12 is the opposite. Remember my trick, drawing that line through the angle. The other side that it touches is the adjacent. The other one is the opposite. Okay, so let's do our trig ratios. The sine of the angle. I don't know what the angle is. I don't care what the angle is. I just want to set up the ratios. So the sine is opposite over hypotenuse. So the sine would be 12 over 13. I'm going to leave a space because I want to do the reciprocals together. So then we've got cosine is the adjacent over the hypotenuse. So that would be negative 5 over 13. Tangent is the opposite over the adjacent, 12 over 5, but we don't like to leave negatives in the denominator, so we're just going to slide the negative sign either directly in front of the fraction, or you can put it in the numerator with the 12. So the reciprocal functions here, cosecant, we just flip over the sign. So cosecant is equal to 13 over 12. Cosine, its reciprocal is secant, so we flip that one over. Again, we don't want that negative in the bottom, so we'll write that as negative 13 over 5. And with tangent, cotangent is the reciprocal of tangent, so we flip it over, so it's negative 5 over 12. Okay, so let's do a couple more just to make sure we've got it. Okay, 9, 12, we are in the first quadrant. So let's see here. 9 would be the distance here. There's our ray. There's the line. 12, right angle. Theta's down here in the corner. 9, 12, what would be the hypotenuse? This is another special 15. One. 15. This is the 3, 4, 5 triangle, but it's multiplied by 3. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. Okay, 9, 12, 15. So let's label our sides. 15 is the hypotenuse. 9 is the adjacent. 12 is the opposite. So our sine ratio is opposite over hypotenuse, 12 over 15. If it needs reducing, then those are both divisible by 3, so that's 4 over 5. Cosine is the adjacent, 9 over the hypotenuse, 15. If we reduce that, that gives us 3 over 5. Tangent, opposite, 12 over adjacent, 9. Reduce it, that's 4 over 3. Cosecant, we flip over the sign, so that's 5 over 4. Secant, we flip over the cosine, so that's 5 over 3. Cotangent, we flip over tangent, so that's 3 over 4. All right, let's do one more. Positive 7, negative 24. That puts us in the fourth quadrant. So we've got negative 24 here, 7 here. Theta is formed with the x-axis. The reason why I want to do so many of these is the trig part's easy, but I keep having people that get tripped up in making the triangle. They put it in the wrong spot. Okay, they put it in the wrong spot. So I want to do several with us here. All right, 7 and 24 don't form a special right triangle. So let's look at what we've got. Is it? Oh, well, that's nice. It is 25. Okay. Well, it's not a special rectangle, but it does come out to be a whole number, so that's good. 25. All right, so let's see here. 25 is the hypotenuse. 7 is the adjacent. 24 is the opposite. So sine of theta is the opposite, negative 24 over the hypotenuse. 25, that does not reduce. Cosine is the adjacent over the hypotenuse. So 7 over 25. Tangent, opposite, negative 24 over adjacent, 7. Cosecant, flip over the sign. So negative 25 over 24. Put the negative in the numerator. Cosine goes with secant. Flip it over, 25 over 7. Cotangent goes with tangent, so flip it over, negative 7 over 24. Just a little note, I meant to mention it while we were doing it. The legs, one or both of those can be negative. The hypotenuse will never be negative. The hypotenuse will always be positive because it's a distance from the origin to that point out there. So it's never negative. Only the adjacent or the opposite can be negative, the x or the y, but not that diagonal distance there. Okay.